Hello and welcome everyone for another Mountz webinar. Today we are going to focus on hand tools and give you the key points to help you choose the right hand tool for your application. There are many types of hand tools in the market. Choosing the right one can be a difficult choice given the multiple situation and applications you will face and the very wide offer the market has. So again, today we are going to give you some key points to help you find the right solution for you and make sure that it brings you satisfaction. Before we jump to that, a few words about who we are. Mountz is an international company with multiple offices around the world, and our headquarters are based in the Silicon Valley in Northern California. Since 1965, we are focused on torque and assembly tools. As such, we were the first company to develop and manufacture an electronic torque analyzer for a famous defense company in the early 70s. Since that time, we have developed 18 different generations of analyzers. And of course, on the side, we also developed and offered multiple generations of hand tools as well as power tools. As of myself, I'm Adrien Auger, and I'm a technical sales manager with the international team at Mountz. I have a 12 years experience in the industry, and through those 12 years, I've met a very wide selections of challenges from customers, always trying to find the right solution for them. Before we talk about hand tools, a few basics on torque. So what is torque? Torque is a force multiplied by a distance. Here on the drawing, you can see the force being the pulling force from the hand, and the distance being the distance between the hand, and the fastener. So this torque will, when applied on the screw, create a tension in the fastener that in itself will create a clamping force on the joint. The aim is to reach the target torque, which generally speaking is going to be 80% of the elasticity of the screw. Indeed, as torque is applied on the fastener will get moving and get more elastic, reaching that point where its optimum tension is going to create the optimum clamping force as well. So obviously, it's very important to make sure that the target torque is reached so that we reach also the target clamping force in the joint. The risk of not doing so are multiple. If we don't reach target torque, the parts will get loose and the assembly will deassemble. If we over torque the fastener, so we apply too much torque, the parts may eventually break, creating as well a deassembly of the parts. In the best case scenario, in that case, the problem will be identified directly on the production line so that the part can be repaired on the production line or on a dedicated rework station. Second scenario is that the parts leave the assembly line, leave the factory, go to your customers, to the market, to the end users, and where the problem will be identified. Obviously, this will create additional issues such as recall of parts on top of the monetary and time consumption. And the worst case scenario would be for the parts to leave the factory and then be responsible for accidents occurring. This can be the case in multiple applications, but just think about an airplane or a car as an example. You wouldn't want a screw to get loose when driving or flying. And of course, this could have also liability repercussions for the production company. So once more, reaching the target torque is very important, and that's why at Mountz, our aim is to make the world a safer place through precision and accuracy. We've been doing so by offering high quality tools to the market, always helping our customers reach their targets. So now let's dive in the hand tools. Hand tools are generally of two categories, torque wrenches or torque screwdrivers. Both are falling under the ISO 6789, which is a manufacturing and calibration norm. And for the screwdrivers, this norm states that the accuracy needs to be plus or minus 6%. Same accuracy for torque wrenches below 10 Newton meters, and plus or minus 4% for torque wrenches above 10 Newton meters. This point makes hand tools very popular in the industry, as these tools are very precise type of tool. Hand tools are also very easy to carry around the production area, and when compared to power tools, they are an easier purchase to make. Hand screwdrivers, as well as hand tools, will have different type of mechanisms, and we will discuss about that throughout the webinar this morning. So what are the criteria you need to keep in mind when looking for the right hand tool for you? Well, first, the target torque is going to be very important. As we will see, different type of tools will have different type of available torque range. So this will already filter through the type of tool that can be used for your application. Second is accessibility. Do you have a lot of space around the assembly, or do you have an access point that is difficult to reach? This will also filter out the type of tool that you can use. The fastener type is the third criteria, where as there are many fasteners in the industry, you want to make sure that you have the right tool that will be allowing you to work with those fasteners. Flexibility is another criteria. On hand tools, there are basically two main types of tools, whether it's a screwdriver or a wrench. The first type will be preset tools. So these tools are internally adjusted, meaning that you need a torque tester to adjust those tools. And when you give it to the operators, this tool is set at a specific torque value, and the operator cannot easily change that. For some operation, this is going to be important to ensure that the target torque is the one delivered. For some other application, the operators need to be able to change the torque value directly on the tool. So for that, adjustable tools exist. Those adjustable tools will have different ways of being adjusted, and we will see about that as well. Final point is ergonomics. We want to ensure that the operators work as comfortably as possible, so ergonomics is going to be a very important criteria. So before we have a deeper look at the tools, whenever you have a question through the webinar, feel free to write it in the chat, and we will answer those questions at the end of the session. So as we've seen, two main types of hand tools, screwdrivers and wrenches. So let's have first a look at screwdrivers. On this image here, we have the FG preset screwdrivers family. And on the screwdrivers, different type of mechanisms exist. The first type would be a clutch type of tool with a simple ball bearing pushing on a clutch. And this will result in a harsher condition when the clutch activates, as well as shock happening on the parts. That's why when developing those tools, we made sure that we had several layers of ball bearing pushing on a cam, and these mechanisms make the FG screwdrivers a much smoother tool to operate, making the operator working in a more comfortable fashion, as well as preventing any damage on the part. So rather than just talking about it, let's have a look at those tools. On the image here, we have the two body types of screwdrivers, the smaller type, going from 0.09 to 2.2 Newton meters, and the bigger type going up to 14 Newton meters. As you can see, the bigger type is delivered with a T-bar to allow the operators to work comfortably when working at high torque values. Taking a closer look at those screwdrivers, you can see that there is no way to adjust it externally. So to adjust it, we need to remove the cap at the back, insert the hexagonal key inside, turn clockwise to increase the torque, counterclockwise to decrease the torque value. So to check the torque set on this tool, we use a torque tester, here an Easy Torque 3, and we make a few rundown until we are satisfied with the torque set on the tool. So here our target torque is 0.6 Newton meters. And once we are satisfied with this setting, we can close the cap back and send it to production. Of course, for our customers, this is a service that we offer for every preset tool. We can preset this tool for you and send it with the proper ISO certification. So the way a Comeover screwdriver works, as you could see already on the values, is that it's going to prevent any over-torquing. And it's going to be much clearer when we look at the torque graph here. In green is the OK area. And as I apply the torque, you see that I am continuously in the OK area. Physically and mechanically, the tool cannot over-torque the application. So this makes this type of tools a very safe type of tool for the assembly. Not only that, but when we developed these tools, we mounted the cam in a very specific way that will eliminate as well end load and side load, basically eliminating any operator's influence on the assembly. So what that means in real life, it means that you give this tool to anybody, it will deliver the same torque after and after. So Preset tools and preset screwdrivers exist with different type of mechanisms. We've just seen the standard type of tool, but we also have one-way clutch or OWC. And these type of tools are going to be used mainly in maintenance and rework stations. So in these tools, the mechanism gives full power to the screwdriver on the loosening counterclockwise direction. So it will be very useful to loosen fasteners while still guaranteeing the cam slipping when reaching the target torque, so that we are sure that in the fastening direction, the target torque is properly reached. Another type of tool are IFR, impact-free resetting. So even though those screwdrivers are very smooth to operate, there can be still a very tiny shock happening when the cam resets. So this can be critical for some very particular applications where the parts really need high-end protection. So these impact-free resetting tools will ensure that by being redesigned internally and really avoiding any shock during the assembly. Preset screwdrivers are also available as ESD and clean room compliance for applications happening in this type of environments. Now let's have a look at adjustable tools. As we've seen, adjustable tools will bring flexibility to the operators by giving them the freedom to adjust the torque directly on the tool. On the right side of the screen, you can see an older model of adjustable tools. And on this screwdriver, there is basically, you can see here, a scale in each pound or Newton meter that will be engraved. So what that means is that first you need to know if you are going to use the tool in one of these units. To set the tool, to set the torque, you simply turn the ring until you reach the dedicated point on the scale. You can see that the scale is going to be quite small, so it can be very tricky to reach the very specific target torque that you aim for. Not only that, but when recalibrating those tools, it's going to be as well a difficult operation, as we would have to go through several springs until we find the right one for the tool at this stage of its life. The ISO 6789, on which we had a few words earlier, states that hand torque tools need to be recalibrated every 5,000 cycles. With our FG screwdrivers, we know that those tools will have at least 20,000 cycles between any recalibration services. You can see also on the other older model that there is no real mechanism preventing the operator from turning the ring and adjusting the torque. So what that means is that the operator may be setting the target torque and by mistake just change the torque while running the tool. So to avoid these issues, we developed the FGA that you can see on the left side of the older tool. The first thing that you will notice on the FGA is the digital display. Right underneath the digital display is a button, and this button will give you access to 5 different units directly on one single tool. So no need to go through different type of tools for different units. they are all included in one single tool. To set the target torque on the FGA screwdrivers, there is a locking mechanism on the other end of the handle. This locking mechanism obviously needs to be unlocked, and then the wheel at the bottom of the tool needs to be turned clockwise for increasing the torque, counterclockwise to decrease the torque. The torque will change by points of 0.1, whichever unit you want. That means that this tool is going to be very precise to set, very easy as well. And when it comes to recalibration, it's going to be a much easier job due to its digital display and software integration. So now that we've seen the torque screwdrivers, let's have a look at wrenches. There are three main types of wrenches available: click, breakover, and Comeover. Comeover wrenches are also called slipper wrenches, Comeover being more American English, while slipper wrenches is more British English. Whichever the term, the tool is the same. So each of these category of tools, click, breakover, and Comeover, will have different ways of working and different implications for your application. Looking at a click wrench, you have here a drawing of the head of a click wrench. What happens when the torque is reached? The tool will click, you will hear it and feel it, and then there is a 3 degrees free movement that the head can move. After these 3 degrees of free movement, the mechanism inside the tool will basically lock, making this tool a straight bar. So what that means in terms of torque application is what you see on this graph. We reach the target torque, the click happens, 3 degrees of free movement, and then the tool becomes a straight bar, making it virtually impossible to avoid what's called guaranteed follow-through torque. It is generally admitted that this guaranteed follow-through torque is going to be, on average, 12% higher than the target torque. So for you, that means that when you have an application, you need to be aware of that and comfortable with the possibility that the torque really applied on the assembly is 12% higher than your target torque. Not only that, with click wrenches, but when we look at how those wrenches work a bit deeper, well, you can see here on this drawing the spring pushing on the pivot block, and the pivot block being basically linked to the head of the tool. So what you can notice is there is a distance between the pivot block and the head, so between the pivot block and the fastener. When you keep in mind that the pivot block is where the torque action is taking place, let's think back about what is torque. Torque is a force times a distance. So that means that this distance is also going to have implication on the torque delivered by the click wrenches. What that means in the real world is that the position on which the click wrench is held is going to change its torque delivery. So of course, that's important because when using click wrenches, you need to make sure that the operators are aware of that and that they always use the click wrench, holding it in the right position. Let's have a look now at breakover wrenches. So breakover wrenches will very roughly work in a similar fashion as click wrenches. Here, the pivot block is replaced by a ball, but the main difference is that the distance between the pivot block and the fastener is out of the body of the tool. So in that case, with breakover wrenches, instead of having 2-3 degrees of free movement, we will have 20 or 90 degrees of free movement. So looking at the graph of torque delivery from a breakover wrenches, it looks rather similar to click wrenches, but once more, the 3 degrees free movement is replaced by 20 or 90 degrees. So that makes it much easier for the operators to be aware that the torque was reached. So it's much less likely to have a follow-through torque so that the operator will not over-torque the application. Another point about breakover wrenches is that, as you will see, they are rather small. This, combined with a wide variety of heads available, here we have open end, flare, box, X-key. We also have ratchet heads. So all these combinations make the breakover wrenches a favorite for accessibility issues as well as delicate electronics fastening. Breakover wrenches will, as an example, be very widely used for SMA connectors. Now that we've seen click and breakover wrenches, let's have a look at Comeover wrenches. Comeover wrenches work very differently than the two previous types. There is still a spring pushing on the ball, but this ball is actually linked to a cam, and when the torque is being reached, the cam will slip, reset, and get ready for the next application. Hence the word Comeover or slipper wrenches. So what that means is that just like for the Comeover screwdrivers we've seen previously, Comeover wrenches will completely eliminate any over-torquing occurrence, making it a much safer tool for your applications. We can see that with a graph of a torque delivery. This looks exactly similar to what we've seen with the FG screwdriver earlier. We reach the target torque, the tool resets, gets ready for the next operation, and so on after fastening after fastening. This, of course, is important. But another important point of the Comeover wrenches is, again, the way it works internally. We can see that there is still a spring. We can see here the self-locking mechanism of the FGC wrenches. But I wanted to show you this graph because it clearly shows that the torque action is actually happening on the head of the tool. So what that means for you is that Comeover wrenches will not be length dependent. You can hold Comeover wrenches on the handle, on the body, or on the head. It will deliver the same torque. So once more, what does that mean is that you can give Comeover wrenches to any of your operator. They will deliver the same target torque. So now that we've seen the theory of those tools, let's look at how they work in real life. So to do that, the first tool we are going to demonstrate is an EPT 75, which is a click wrench. This click wrench is adjustable, so we can see the foot-pound scale on one side and the Newton meter scale on the other side. I'm going to set this tool to 17 Newton meters. And I'm going to put it on a sensor. This sensor is linked to a PTT torque analyzer, and this torque analyzer is set in first click. So we will have here the click value, but we will have another very interesting information. So let's go ahead and let's make one. So the information what the torque analyzer displays is we clicked at 16.6 Newton meters, but the follow-through torque was 20.3 Newton meters, almost 4 Newton meters higher than the target torque. Let's make another one. Here, I'm much closer. I have only 1.2 Newton meters difference between the click and the follow-through torque. But you can see that repeatedly, I'm always applying a higher torque value than the torque set on the tool. Now, let's have a look at what happens when I hold the wrench at a different level on the tool. Mountz click wrenches are delivered with a grip, and this grip, of course, has a groove here, clearly indicating where the tool needs to be held to be consistent with a scale engraved on the tool. So now I'm going to hold the tool much closer to the head here, and let's see what happens when I do exactly the same operation with the tool still set at 17 Newton meters. I reached double than my target torque. Tool is set at 17 Newton meters. It applied 33 Newton meters. So of course, in real conditions, you want to absolutely avoid that on your production and assembly stations. So that's why it's, again, very important when using click wrenches that the operators are trained and explain those very important points, but that you always keep that possibilities in mind when choosing the tool for you. Another point about hand tools, and more specifically adjustable tools, you see that we have the scale here, and for adjustable tools, it's always very important to set the tool back to the minimum value at the end of every shift. The reason for that is the spring is going to be a bit lighter than with internally preset tools. So that means that we need to set those tools back to the minimum value at the end of every shift to avoid any deviation of the torque delivered through time. Once again, this is not the case with preset tools, which are built to be left at their preset torque value for the operation throughout the calibration cycles. So now that we've seen click wrenches, let's have a look at breakover wrenches. So here we have a TB wrench, which is a Mountz wrench. You can see that it's roughly the size of a pen. And this type of tool is a preset tool. Just like the others, to set the tool, we remove the cap at the back, insert the key clockwise to increase the torque, counterclockwise to decrease the torque. So those wrenches, again, as we've seen during the presentation, can come with different type of heads. Here we have a 9mm open end, and it's fixed to the tool. So it comes as one with the tool. There are also other type of breakover wrenches available. And here you will see the difference is a screw. And what that means is that we can loosen that screw, remove the box head, insert a new head, and we have a new tool. A very important point, and that's true with Mountz TBI wrenches, is that all of our heads have the same length. That means that when the tool is set at a specific torque value, you can replace the heads. The torque value remains the same. So that's very important because you don't need to reset the target torque every time you change the head. So let's look at how this tool operates. Back to the EasyTorque 3, 1 Nm target torque. We reach the target torque, the tool breaks at 90 degrees, and then I reset it, and I'm ready for the next operation. As you can see, with this level of action, it's very easy for the operators to notice when the torque is reached, so it makes the over-torquing occurrence much less likely than with click wrenches. Due to their mechanisms, breakover wrenches, just like the click wrenches, are also length dependent. So that's why we deliver those tools with a groove here to clearly indicate where the tools need to be held for the fastening operations. Now, let's have a look at the Comeover wrenches. This is an FGC 10 wrench with a torque range from 2 to 10 Nm. As usual, to set this preset tool, we remove the cap, insert the key, clockwise, increase, counterclockwise, decrease. One thing that's specific with this tool is that it has a self-locking mechanism internally, so that when we remove the setting key, this mechanism will lock, guaranteeing a torque setting that will last for at least 10,000 cycles, which is twice as much as the recommended 5,000 cycles from the ISO 6789. When we look at how these tools operate, you will see that it's roughly the same torque deliverance as with the Comeover screwdrivers. So we have our tool. Let's change our target torque, 1.8. Reset. So we have our tool, and you can see that once again, I cannot over-torque the application. This is again very noticeable when we use the graph function. fastening after fastening, I am always in the OK area. Now, we talked about length dependency earlier. So I've been holding the tool on the handle. Let's see what happens when I handle a tool on the head. Same torque delivery. So this is the clear demonstration that Comeover wrenches will not be subject to length dependency. So to sum up, I wanted to give you typical application, one typical application for each category of tool. We started with preset Comeover screwdrivers, and these tools, due to their torque range from 0.09 to 14 Newton meters, will, generally speaking, be more used for critical low torque applications. The operators generally will hold the tool vertically so that it's also comfortable to work hours after hours. Click wrenches will have a torque range that goes quite high. In Mountz tools, we go up to 1,200 Newton meters. So these tools will, generally speaking, be more used for higher torque applications where accuracy is demanded, but is not that crucial. Something important also to keep in mind with click wrenches is we've talked about follow-through torque. This follow-through torque will have the tendency to get less important with higher torque applications. Breakover wrenches, such as the TB and TBIH wrenches, will, generally speaking, be more used for parts with accessibility issues or medical electronics defense type of fastenings. These tools have a range from 0.09 to 5.65 Newton meters. So this makes them very favorite again for this type of applications. Finally, the Comeover wrenches with their torque range from 1 to 125 Newton meters will be used for critical low and medium torque applications. These are the tools that will be used when accuracy and repeatability are very important for the assembly and where you cannot accept any quality issues on the parts. So we started today's webinar by seeing the different type of tools, a lot of choice for many applications, a lot of different repercussions depending on the type of tool you use. And I hope that I have already answered some of your questions. And of course, if you have any questions now, feel free to write them in the chat, and Tom will read them out loud so we can answer them right away. Tom, do we have any questions?
Yes, Adrian, we have a couple of questions. The first one is, with the FGA adjustable screwdriver, what is the scroll increments?
The increment is going to be 0.1, whichever the unit is used, whether it's Newton meter, inch pound, etc.
Okay, and the next question is with the click wrench and the extension bar.
Yes, we can use extension bar, but again, what we need to keep in mind when using extension bar is we go back to the basics of what is torque, and it's a force time a distance. So when we add distance to wrenches, it's important that in that case, the tool will be calibrated with that extension as one, so that we can set the tool with the extension and measure the torque applied on the output of the extension.
Okay, and that looks to be all the questions, Adrian.
Okay. Well, if you watch this video on demand, feel free to write your questions to the email address that's displayed here, international@mountztorque.com. Thank you very much, everyone, for joining us and watching this video. Again, I hope that this was a real guidance for you, and we will see you next time. Bye-bye.